Welcome to Learning with Philemon. In this video, we will continue to explore the concept of isomerism. In the previous videos, we have looked at structural isomers and geometric isomers. In today's video, we will focus on optical isomers. Optical isomers have the same molecular formula and structural formula, but are non-superimposable mirror images of each other. The term non-superimposable will become clearer as we work through some examples in the next slides. Let's first take a look at a molecule that does not have an optical isomer. Bromochloromethane has the following three-dimensional structure. Remember that the dashed bond means that the atom is coming out of the screen, and the dotted bond means the atom is going into the screen. Its mirror image would look like this. These two molecules are actually the same. As can be seen in the animation, if you rotate the molecule by 180 degrees, it is exactly the same as the second one. It helps to build molymods to visualize this. If you rotate this molecule to see this view, it is evident that it has a plane of symmetry. It is an achiral molecule that has no optical isomers. To have an optical isomer, there needs to be a carbon in the molecule that is bonded to 4 different groups. This is called a chiral carbon and is denoted by an asterisk. The mirror image of this molecule would look like this. It seems that if you rotate the first molecule, it will be the same as the second, as in the previous example. However, this is not the case. Notice in the animation, when I rotate the first molecule, the red and the white atoms are aligned. However, the blue and the green atoms are in the wrong place. This is something you can see in your daily life as well. Your right hand is a mirror image of your left hand. However, no matter how you rotate your left hand, it cannot occupy the same space as your right hand. This is what non-superimposable means, when two objects cannot occupy the same space. The term chiral comes from the Greek word cheri, which means hand. Note that chiral molecules do not have a plane of symmetry. This demonstration shows that these two molecules are different from each other. They are optical isomers. In the next slide, we will see how we distinguish between them. To name optical isomers, we need to assign priorities, as we did for EZ isomers. For more on this, please watch the geometric isomers video. The highest priority number is assigned to the atom with the highest atomic number. So the priorities would be as follows for the two molecules. The second step is to rotate the molecules so that the atom with the lowest priority is pointing away from you. In this view, the hydrogen atom cannot be seen as it is directly behind the carbon atom. The third step is to see in which directions the numbers increase. If the priorities increase in a clockwise direction, the optical isomer is designated an R, coming from the Latin word rectus, which means right. This isomer is called R-bromochlorofluoromethane. If the priorities increase in an anti-clockwise direction, the optical isomer is designated an S, coming from the Latin word sinister, which means left. This isomer is called S-bromochlorofluoromethane. Now let's take a look at which physical property this different spatial arrangement affects. Optical isomers have the same chemical and physical properties. They only differ in one physical property, the angle of rotation of plane polarized light. Let's see what this means. Light can be described as an electromagnetic wave. These waves can be oriented at any angle as can be seen here. Using a filter, we can allow only one orientation to pass through. In this case, we kept the vertical orientation. Light consisting of electromagnetic waves with only one orientation is called polarized light. If this light passes through a sample containing only the S optical isomer, the light is rotated in one direction. If the light passes through a sample containing only the R optical isomer, the light is rotated but in the opposite direction. Because of this property, optical isomers are used in sensors and liquid crystal displays, or LCDs. If the sample contains equal amounts of the R and S isomers, then the light is not rotated, as the effect of each is cancelled out. This type of mixture is called racemic. Enantiomers is another way of saying a pair or set of optical isomers. When developing new medicine, scientists check whether the molecules they have synthesized have optical isomers. This is crucial as sometimes only one of the isomers is effective. In some cases, one of the optical isomers can be harmful and needs to be removed. For more on this, check the article on thalidomide in the description. Thank you for listening. To consolidate your learning, please try the questions in the description. If you haven't already, please subscribe for more content. Stay curious.